Hello guys, so we are continuing what we started yesterday with absolute value equations. If you did not watch that video yet, you really should before you start this one because it's sort of an extension of that. Everything that we learned yesterday still applies, but there are some special cases that come up when you solve absolute value equations. There are, it says two, there are actually three special cases. No solution, so it's possible to solve an equation, but then it turns out not to have a solution. One solution, I don't know if you noticed yesterday, but all of those problems had two answers to them. It is possible to just have one. And then extraneous solutions. This is where you actually get two solutions by solving them, the equation, but then it turns out one of them isn't right, and I have to sort of teach you how to spot that. Also, there are some problems that look like they should be these special cases, but they aren't. They're just normal problems. So in the lesson today, there's going to be a couple that are just normal problems. All right, so yesterday we learned about absolute values in general. So over here, you see absolute value of -2, absolute value of +2. Both of these work out to be 2. So in a sense, whatever's inside those absolute value bars turns positive. Absolute values, therefore, are always positive. Now, the outcome is always positive. The input, what goes into the bars, could be negative, could be positive. When it's a variable, we don't necessarily know whether it was positive or negative, but we know the outcome would have to be a positive number. How do I want to do this? Positive number. So the I'm writing this wrong. The outcome is always a positive number. Therefore, the absolute value equal to a negative number is impossible. I should have paid attention to what I was trying to say. The absolute value of a negative number is impossible. What that means is, if you ever have the absolute value bars on one side of the equal sign and a negative number on the other side of the equal sign, there is no solution to that equation because the whole premise is impossible in the first place. So I will, when we get to the examples, you'll see what that looks like. So an absolute value is always going to equal a positive number. When that happens, you work it out, you get two solutions. If it's equal to a negative number, that's impossible, so there's no solution. What if an absolute value is equal to 0? Well, if you do what we did yesterday and you split it in two, x equals +0, x equals -0, that kind of doesn't make sense. There's no such thing as +0 or -0. So instead of doing that, if you have an absolute value equal to 0, you just drop the absolute value bars, make it equal to 0, and then go through whatever steps you need to solve it from there. And that's how you only get one solution. So equal to a positive number is going to be two solutions. That was what happened yesterday. Equal to a negative number, impossible, no solution. Equal to 0, that's going to have one solution. And then, like I said before, sometimes everything looks right, you work it out, you get two solutions, but then you substitute the solutions back in, which we really haven't done, but you know when you solve equations. You can always plug your answer back in and see if it's right or wrong. So when you plug your two answers back in, sometimes one of them works and one of them doesn't work. The one that doesn't work is extraneous, which I think is just a smart sounding way of saying extra. That solution is extra, it does not really work. Often, but not always, this happens when the equation has an extra, I didn't mean to scribble that out, I meant to highlight it, an extra variable. So when we get to examples, I'll show you what that means. Those are going to be down toward the bottom of the page. All right, so as always, I'm going to do the evens. I'm going to ask you to do the odds. Show your work where it makes sense. When you're done, check your answers. Don't forget to write your score on the page or put it in the comments. So let's do this. So number 2 is going to be just quick and easy. We have absolute value of x equals a negative number. It's impossible for an absolute value to equal a negative number. Therefore, this is no solution. There's really no work to show. You just have to recognize the fact when an absolute value equals a negative, there's no solution. Let's just play devil's advocate for a minute, though, and say, treat this like we did the problems yesterday. So you drop the absolute value bars, you set x equal to -10, and you set x equal to +10. So that's pretty much what we did yesterday. And you go and, I'm doing air quotes here, you can't see me, but you go and solve this. I did air quotes when I said solve it because it's already solved. X is isolated, X is isolated. Well, remember how absolute values, how equations work. When you get an answer, you should be able to plug it back in and check it. So absolute value of -10 equals -10. Absolute value, plug this one back in and check it. +10, does that equal -10? Well, what do absolute value bars do to this negative sign? Makes them go away, or makes it go away. Does 10 equal -10? No, it doesn't. So that's not right. Over here, what is the absolute value of +10? It's still +10. Does that equal -10? No. So when you plug both of these answers back in, they do not work. So again, there is no solution. Now, this looks like a bunch of gibberish and miscellaneous unnecessary work, and truthfully it is. If you can recognize that you have an absolute value equal to a negative, then you just write no solution and that's it. Okay, probably beating a dead horse at this point. Let's look at number 4. Absolute value of x equals 0. Again, what I said before, you set this equal to 0 and solve it, again with the air quotes. I say that because there's nothing to solve. X equals 0 is the answer. If you tried to do what we did yesterday with this and split it in two, you go x equals 0, x equals -0. You're like, well, -0 is not a thing. It doesn't really make sense. There's just one solution, x equals 0. All right, let me be consistent. Go scroll down and check these two answers just so you know I'm not making mistakes. No solution, 0. All right, let's come back up here. Number 6. N absolute n over 3 equals -4. Once again, we have an absolute value equals a negative number, so you can simply write no solution and move on with life. You could do what I did before, where you actually split it up and try to work it out and then check your answer, but it's not going to work. Nothing will give you a -4. It's just no solution. And tell you what, I'll go ahead and do number 8 as well, and then we can check these both at the same time. So absolute value of p over 10 equals 0. Once again, equal to 0 means there's only going to be one solution, so all you have to do is do p over 10 equals 0. Equals 0. If we want to isolate this p, we do have to multiply both sides by 10. Opposite of divide is times, and that cancels out. You multiply the other side by 10, and you still get 0 for an answer. So you're not going to have two answers there, you just have one. Let's check 6 and 10, or 6 and 8. No solution, 0. So this whole first page is what you might call the easy page. Oh, I feel a sneeze coming on. Forgive me if it happens. So all of these, no solutions and zeros. That's pretty simple. So 1 through 7, when you do the odds, not going to be much work to show. It's just fairly straightforward. Let's continue on. Clearly, number 10 looks a bit more complicated. Now remember, when you're doing absolute value equations, if there's a number outside of those absolute value bars, you do have to eliminate it or transport it over to the other side of the equal sign. You always have to do that first before anything else. So I'm going to add 6 to both sides. I get absolute a minus 8 equals -12. But then here, we do have an absolute value equal to a negative. That automatically means no solution, and we're done. I didn't call it up here because there was still a step to do first. You want to do that first step before you jump to the conclusion of no solution. But once you have the absolute value equal to a negative, you're pretty much done. Number 10, scroll down, no solution. Let's look at number 12. I think 12 is going to be easy also. Yeah, once again, we do have a number outside of those absolute value bars. We need to eliminate it. I'm going to go ahead and rewrite the problem first. So this is divide by 9. The opposite of divide is times, which will cancel that out. You do have to multiply the other side as well. You get absolute m minus 1 equals, what's 0 times 9? 0. So this is equal to 0. It means we're going to have one solution. Now let me go back to the first couple of problems where this happened. In number 8, it happened. The answer was 0. In number 4, it happened. The answer was 0. Does that mean the answer is always going to be 0 and you just write down 0 and you're done? No, it does not mean that. all it means is you don't have to split this into two separate equations. You just solve it once, m minus 1 equals 0. But in this particular problem now, I need to add 1 to both sides to isolate the m. So this only has one solution, but instead of the solution being 0, the solution is 1. Let's check number 12. There it is, and the solution is 1. Tell you what, let's do the old-fashioned kind of check as well. That's where you take the original, the original equation, absolute m minus 1 divided by 9 equals 0. But instead of writing m, I put the solution in its place, 1, and then work it out. So sort of an order of operations thing. 1 minus 1 is 0. The absolute value of 0 is still 0. 0 divided by 9 is 0. 0 equals 0, which means that 1 is the correct solution. So if you don't have an answer key, let's say you're taking a test and you want to be able to check your work before you submit it and get it graded automatically, you can plug your answer back in and check it and make sure it works. All right, let's get back on track now. Number 14. There are people who would look at a problem like number 14, say, hey, it equals a negative. This must be no solution. I don't want to show my work anyway, so I am done. And then you go down and you check number 14, and guess what you see? There are two regular old solutions. So what's going on here? Have I been lying to you? No, I haven't been lying to you, but it's an easy mistake to make. So the rule is, if you have an absolute value equal to a negative number, there is no solution. In number 14, we don't have an absolute value equal to a negative number. We have an absolute value minus 7 equals a negative number. We need to deal with that negative 7 first, which means add 7 to both sides. And when you do that, you get absolute 7x plus 8 equals 1, and 1 is positive. So this is a regular problem with two answers. So that's what I said before. Sorry about all the scrolling up and down. I don't even remember where I wrote this. Oh, right here. Also, I didn't mean to do that. What did I do? Also, problems that look like special cases but aren't. So this is one of those problems that looks like it might be a special case because it starts out with a negative, but after the first step the negative goes away and it just turns into a regular problem that you can solve. So this is now a review of yesterday. You split this into two separate problems, 7x plus 8 equals 1 and 7x plus 8 equals negative 1. One positive, one negative. Then work them both out separately. So minus 8 on both sides, you get 7x equals negative 7. Divide by 7, x equals negative 1. And then over here, subtract 8 on both sides, 7x equals negative 9. Divide by 7. Of course, 7 doesn't divide into negative 9, so we just leave that negative 9 sevenths. So negative 1 and negative 9 sevenths. And there it is. Now we have the right answers. So the fact that it equals a negative does not automatically mean no solution. Any extra numbers outside of the absolute value bars have to be brought over to the other side first. Then you make that conclusion. All right, we're on our last page. Yes, we are. Number 10. So what do? Well, we got this 10 over here. It's not in the absolute value bars, so I have to subtract it over to the other side. Negative absolute, negative 8x minus 8 equals 32. This negative sign is not in the bars, and what do we do with that? Well, one thing you cannot do, you cannot distribute it in. That's not a thing you want to do. That'll mess everything up. Absolute value bars are kind of like parentheses sometimes, but not when it comes to distributing a negative. So what you do is you treat this negative sign as though it's a negative 1 and just divide it over to the other side. You get absolute negative 8x minus 8 equals, sorry, let me write this a little neater, more neatly, whatever. 32 divided by negative 1 is negative 32. At this point, we have an absolute value equals a negative number, so we don't have to do anything else. This is a no solution problem. Number 16, let's check it. No solution. There we go. Okay, so the special cases so far are no solution, one solution, tricky questions that look like they might be no solution, no solution, but they really do have solutions. And now we get up to the last four. So this is the other type of problem. Let me scroll back up to the notes and review what that said. Sometimes you get two solutions, so it's going to work out. But when you substitute them back in, like I did on that one example, I showed you how you can substitute back in, one doesn't work. The other one does, but the one that doesn't work is called extraneous. And this often happens when there is an extra variable. So what does extra variable mean? On all the problems we've done so far, the variable has been located inside the absolute value bars. That's pretty standard. You're going to see that over and over and over. The variable is inside the bars. On number 18, we do have a variable inside the bars, but there's another one over here. And I apologize. That's supposed to be an n, not an x. That is my fault. Did I do that on any other problems? Not 17, not... Okay, just this one. So you're going to have to pretend that that x is an n, all right? Bear with me. In fact, I'm just going to rewrite the whole problem. Absolute n minus 4 minus x equals negative 2 plus 3n. Okay, anyway, oops. So we've got one variable in and one out. So we're going to go ahead and solve this, try our best. First, we've got negative 10 or minus 10 that I'm going to add over to the other side. Make sure you pair it up with a like term. Don't put it underneath the 3n. That's not a like term. Put it underneath the negative 2. And these cancel out. Absolute n minus 4 equals negative 2 plus 10 is 8 plus 3n. Now this is where we split into two separate problems. We have n minus 4 equals 8 plus 3n, and n minus 4 equals, all right, what do we do with the other side? This is where we make this side negative. When it's a number, you just make the number negative. But what if it's a whole expression, like 8 plus 3n? Well, you make them both negative. Negative 8 minus 3n. It's that simple. If one of them was already negative, we'd switch it to positive. So you just reverse it or change it around, however you want to say it. Okay, let's solve these. First, this one over here. Like terms on each side of the equal sign, I need to get them together. So minus n, negative 4 equals 8 plus 2n, right? 3n minus n is 2n. I'll subtract 8 on both sides. Negative 12 equals 2n. Divide by 2. N equals negative 6. And then over here, we have like terms on both sides of the equal sign. I'm going to go ahead and add 3n to both sides. N plus 3n is 4n minus 4 equals negative 8. Add 4 to both sides. 4n equals negative 4. Divide by 4. N equals negative 1. So I have two answers. Now, what you need to do, and this is a drag. It's not going to be fun. You probably dread having to do this, but it's really your only choice. You have to go back to the original problem, plug in a negative 6, and plug in a negative 1, and work it out and see what happens. Now, I did not give myself a ton of room here. I'm going to do something that I could not do in the old days with a chalkboard or pencil and paper. I'm going to just make it smaller. And let's check the work. So I'm going to plug in a negative 6. I have absolute negative 6 minus 4 minus 10 equals negative 2 plus 3 times negative 6. And even that is a problem. I got to move it over here. So what did I do? I put this negative 6 here and here, there And oops, that's not an absolute value, it's just times -6. Now I'm going to work this out. -6 minus 4 is absolute -10 minus 10. Absolute -10 is positive 10 minus 10. That works out to equal 0. The other side, -2 plus 3 times -6 is -18. -2 plus -18 is -20. Does 0 equal -20? No, they're two different numbers. That means -6 is an extraneous solution. It does not work. Can you have two extraneous solutions? I suppose it's possible, so let's go ahead and check. -1 minus 4 minus 10 equals -2 plus 3 times -1. So now I'm plugging this -1 in here and here, put it there and there, and I'm going to work this out. So -1 minus 4 is -5. Absolute value of -5 is positive 5. 5 minus 10 is -5. Do the other side. Multiply first. -2 plus 3 times -1 is -3. -2 plus -3 is -5. Does -5 equal -5? Yes, it does. So that means -1 is a solution. -6 is an extraneous solution. I check the answer there, and you see -1 is the only solution listed. Let's look at number 20. Well, here, let me leave that on the screen for a second. You can pause it if you're looking it over. Okay, number 20. Again, we've got our variable inside the brackets, or the absolute value bars, like we expect, but there's also another variable outside, an extra variable, as I called it. Does that mean this will have an extraneous solution? No, it means it could have an extraneous solution. The only way to know for sure is to solve it. Okay, there's nothing extra on these absolute value bars that you have to move over to this side. There's no like first step like there was here where we had to move the 10 over. So we can go ahead and, let me erase that, split this in two. 2r equals 6 plus r, and 2r equals, now how do we make this whole side negative? -6 minus r. And let's work this out. First one, I've got like terms here and here. I need to get them together, so I'll subtract r. 2r minus r is r. Bring down the 6, and we're done there. This one, this side, we need to get those r's together, so I'm going to add r to both sides. Uh-oh. 3r equals -6. Divide by 3. R equals -2. All right. Because I'm getting cut off by announcements, I'm going to skip down to the answers. Both of them count, so they are both right answers. So sorry about this. If we take the time to plug in the 6, we end up with 12 equals 12, so that's good. If we plug in the -2, this works out to be -4 absolute value, which is +4, and the other side is also +4. They both work, so they are both solutions. Okay, I'm going to stop here because of the announcements. Contact me if you have any questions. Good luck. Have a